Assalamualaikum and Hi We are from Group KK6 who would like to present our integrated project entitled The Production of Maleic Anhydride. So let's begin with the introduction to our project. Firstly, maleic anhydride is also known as furan 2,5-dione and the molecular formula for it is C4H2O3. Maleic anhydride are colorless crystalline solid which has a boiling point of 200.1 degrees Celsius. Maleic anhydride can be presented and have potentials in many areas in industry, and here are some examples for the usage of maleic anhydride. Firstly, it is used in the manufacture of unsaturated polyester resins or UPR. Secondly, it is involved in the production of 1,4-butanediol. Thirdly, it is also used in lubricating oil additives. And lastly, it is used in smaller applications such as in food industry. Let's proceed to the economic issues for the production of maleic anhydride. In 2017, the global production of maleic anhydride was estimated at 1,800 kilotons. By 2022, the market is expected to reach 2,200 kilotons with a CAGR of 3.69%. According to the report, the demand on the market was 4,500 kilotons per year in 2017 and it annually grows at 4.5%. So, it is estimated to be 5,607 kilotons in year 2022. And here are the values for the demand and supply. And as shown, the calculated plant capacity for our project is 50,334.35 tons per year. That's all from me. Thank you.
I will present the process description of the production of maleic anhydride. The production of maleic anhydride is an oxidation process of N-butane containing vanadium and phosphorus oxide as the catalyst. At the first stage, the air and the butane are being fed to the packed bed reactor, and the reaction is carried out in the packed bed reactor at a range of temperature of 390 degrees Celsius. The off gas from the reactor is being cooled in the heat exchanger. Then 50% of the maleic anhydride is being condensed in the partial condenser, while the other 50% is being fed to the scrubber and form malic acid by the reaction with the water in the scrubber. Malic acid is then thermally dehydrated from an aqueous solution to the maleic anhydride in the first distillation column. Maleic anhydride is further purified from impurities by fractional distillation in the second distillation column. In the production of maleic anhydride, there are one main reaction and four side reactions. The conversion of butane is 85%, while the selectivity of maleic anhydride, acetic acid and alkylic acid are 70%, 1% and 1% respectively. Therefore, the reaction rate, which is R1, R2, R3 and R4, is being calculated as shown in the slide. Next, we assume our inlet molar flow rate of butane is 100 kmol per hour. By using the formula, inlet molar flow rate equals to outlet molar flow rate minus the alpha R, where alpha is the stoichiometric coefficient of the equation, and R is the reaction rate, we found out that our outlet molar flow rate of butane is equals to 15 kmol per hour. Therefore, the molar flow rate is being converted to the mass flow rate by multiplying the molecular weight of butane. The same way will be done for the other component as well to calculate the mass balance of the reactor. The total molar flow rate for the inlet and outlet is balanced. For energy balance, there are a few assumptions made. The first assumption is the process is in a steady state process, and the reference temperature is 298.15 Kelvin. Next, the gas is assumed to be in an ideal gas state. The inlet enthalpy and outlet enthalpy is being calculated by using the formula integration of Cp dt, and we found out that the inlet enthalpy is 1086.49 kJ per kilomole and the outlet enthalpy is 5561.05 kJ per kilomole. And the heat of reaction is being calculated for the main and the side reaction, where the formula is heat formation of the product minus the heat of formation of the reactant. Next, the value of Q is being calculated, and we found out that it is negative 1.449 times 10 to the power of 7 kJ per hour. Therefore, we can conclude that the reaction in the reactor is exothermic reaction.
Assalamualaikum and Hi. So for my part, I will start with safety issues. These are the materials involved: N-butane, MA, carbon monoxide, acrylic acid and acetic acid. For the N-butane and acrylic acid, acetic acid, we need to keep away them from any open flames or hot surface. And for MA and carbon monoxide, we need to wear proper PPE in handling it. We also need to store N-butane where temperature not more than 52 degrees Celsius. And for the carbon monoxide, we need to remove from all ignition source. And the last one I want to emphasize is maleic anhydride and acrylic acid, acetic acid. We need to store it in well ventilated space. For the environmental issue, here are the list of waste generation, which are wastewater, carbon monoxide, acrylic acid and acetic acid. Wastewater will be treated with coagulation and flocculation using various chemical reactions. Carbon monoxide is sent to the afterburner. Acrylic acid is treated in an anaerobic membrane bioreactor. And the last one, acetic acid, can be treated to an authorized waste incinerator for solvent with energy recovery. The Environmental Act involved in this production is Environmental Quality Clean Air Regulation 2014 and Environmental Quality Act 1974. For the heat and mass transfer part, we will focus on the heat and mass transfer on the packed bag reactor R101. The overall reaction is exothermic, meaning it releases heat to the surrounding. There are few assumptions made. First one, reaction is in steady state. Next, the thickness of both reactor wall and jacket is 0.1, which are made from stainless steel. The ratio of the height of reactor to the inside diameter of reactor is 3:1. The residence time is assumed to be 1 minute. And these are the following information involved in the calculation shown in Appendix C. Since the Reynolds number is 28,612.44, which are more than 3,000, the flow is turbulent flow. Thus, the rate of heat energy Q is 739,672.98 watt. For the mass transfer, N-butane denoted as A, diffusing through oxygen, which is component B. Diffusion coefficient of gas, DAB, can be determined by using Fuller-Schechter-Gidding formula. The equation is as shown here. The calculation also attached at the Appendix C in the report. Here, conclude the flux is 3.347 kmol per meter square per second. These are factors influencing heat and mass transfer rate. According to Fourier's law, there are few factors affecting heat transfer rate, which are temperature difference, convective heat transfer coefficient, surface area, thickness of wall, thermal conductivity. And for the mass transfer rate, is affected by following factors: diffusion coefficient, convective mass transfer coefficient, and the last one, concentration gradient.
So for chemical engineering reaction part, in our production, which is maleic anhydride, packet bag reactor PBR is being used because it's suitable due to the reaction between butane and oxygen, which are in gas phase. A packet bag, also called a fixed bed reactor, is essentially a tubular reactor that is packed with solid catalyst particles. In our project, vanadium and phosphorus mixed oxides is being used because it will access of void space and carry out reaction. There are a few advantages if we are using PBR, which it has a higher conversion per unit mass of catalyst, low operating cost, and suitable continuous process, which is gas flow. The general mole balance is rate flow in plus rate flow out plus rate generation equals to rate accumulation. We have made some assumption on this PBR, which is have no radial gradient in concentration, temperature, and reaction rate. The system in at steady state and no accumulation product in the reactor. The final expression we will have like this. So for the kinetic rate equation, we see that 2 butane plus 7 oxygen plus equals to will produce 2 maleic anhydride plus 8 water. The Rate's law expression we got like negative RA equals to KCA squared C87, and the final expression we have like this, and the summary we can see there. In the production of maleic anhydride, vanadium phosphorus oxide is being used as catalyst. The side reaction of oxidation and butane is carbon monoxide, carbon dioxide, acetic acid, acrylic acid, and water. And there are few separation methods in our process is being used in order to get high purity of product in our production. Maleic anhydride with purity of 99% is being obtained. So to stable the product, maleic anhydride melt must be heated stable for 2 hours at 140 degrees C. Maleic anhydride can be stabilized with phenolic compounds Maleic anhydride is combustible and will finally disperse particles from explosive mixture in air. So keep away the MA from fire source.
Next, we move to the last part of presentation, which is programming. Before we start writing the code, we need to do both algorithm and flowchart so that our work will be easy later. For the algorithm, first we need to set the reaction shape of all the reactions involved. We have 4 reactions total, thus we have 4 reactions rate. R1, R2, R3, and R4. Then we can fix the stoichiometric coefficients of all the reactions involved. Then we can insert the input molar flow rates of all the components involved. We have 9 components total. Then after that, we can calculate the output molar flow rate. Then we can set the molecular weight of all the components so that we can convert the molar flow rate to the mass flow rate instead. Then we can total up both input and output mass flow rate and then tabulate in the table. Lastly, we can check whether our mass balance are balanced or not. After writing the algorithm, we can represent the information for the algorithm into a diagram which can be called as flowchart. Flowchart will always start with start and end it with end. Here we show you our flowchart. After we finish with both algorithm and flowchart, we can start writing the code. Here we will show you what will appear at the comma window. The program will ask you to insert the input molar flow rate of all components. Then the output will be calculated by the program and the result will be displayed at the comma window in a table form. Here we can show you that our mass balance is balanced. Lab need to be validated with manual and SuperPro calculation. Of course, there are some errors involved. So here we show you our comparison between manual, SuperPro, and MATLAB calculations. To sum up our presentation, maleic anhydride is useful in the manufacture of unsaturated polyester resin and also in the production of 1,4-butanediol. N-butane is used in large scale to produce maleic anhydride. In 2017, global production of maleic anhydride was 1,800 kilotons and expected to reach up to 2,200 kilotons by 2020 with CAGR 3.69%. Our plant's capacity is 5,745.93 kg per hour to fulfill 1.44% of the demand. There are several ways to produce maleic anhydride, but in this process, we use the oxidation of N-butane instead. Overall mass balance are balanced and the reaction is exothermic because Q is equal to negative 0.1449 10 to the power of 7 kJ per hour. Overall heat transfer is 709,672.891 and heat is transferred by both conduction and convection. Meanwhile, for the mass transfer, It is occurred by molecular division with Ja equal to 3.347 10 to the power of -7 kmol per meter squared second. For reactor, we use packed bed reactor made from stainless steel because we use catalyst and also for other several reasons. And lastly, MATLAB is used to calculate our mass balance as well.